I'm going to start recording. And Gene, I'll hand it to you.
Okay. All right. This is going to be E7, the practical circuits. And the first one is digital circuits, digital circuit principles and logic circuits, classes of logic elements, positive and negative logic, frequency dividers, and truth tables. Okay, which circuit is bistable? That would be a flip-flop.
Yeah, important thing to remember about a flip-flop is once you move it to one state, it isn't going to bounce back unless you trigger it to go back. So you need a trigger to flip it back and forth. So if you imagine a light switch, you have to flip it up to turn it on and flip it down to turn it off. So that's kind of a crazy analogy.
Okay, the next one is, what is the function of a decade counter? It produces one output pulse for every 10 input pulses. Okay, which of the following can divide the frequency of a pulse train by 2? The answer would be a flip-flop. How many flip-flops are required to divide a signal frequency by 4? That would be 2. For each flip-flop, you get 2. So then the answer would be the end result is 2. Okay. Which of the following is a circuit that continuously alternates between two states without an external clock? That is in a stable multivibrator. What is a characteristic of a monostable multivibrator? It switches momentarily to the opposite binary state and then returns to its original state after a set time. What logical operation does a NAND gate perform? It produces logic. Let's see something here. I gotta move something. It produces a logic 0 at its output only when all inputs are logic 1. And there's the little symbol diagram for a NAND gate.
Yeah, you can see in the truth table that the output is going to be 1 anytime that the input isn't both 1 and 1. So that's the only time that you're going to get a logic 0.
All right. What logical operation does an OR gate perform? It produces logic 1 at its output if any or all. And there again is the symbol for an OR gate.
Yeah, so you can see in the truth table for this one, you're going to get a logic 0 only if the inputs are both 0, and a logic 1 in any other combination.
Okay, what logical operation is performed by an exclusive NOR gate? It produces logic 0 at its output if only one input is logic 1. And there again is the little symbol diagram for the NOR gate. And there's
Is
the
that
truth.
different than if it was an exclusive NOR gate?
Yeah, if you look at the truth table, if you remember back on the previous one where we had for an OR gate, if you had either one or both
Or both.
inputs as logic 1, you would get a logic 1 out. If it was an exclusive OR gate, then you would only get the logic 1 when only one of the inputs. If both of them, you would come back with a logic 0.
Okay.
And that's
What's the term, exclusive?
yeah, exclusive, yes.
All righty. What is a truth table? It's a list of inputs and corresponding outputs for a digital device.
And you can see it shows you the inputs and the outputs of the different state combinations.
What type of logic defines 1 as a high voltage? That would be a positive logic. Okay. Section B, which is amplifiers, and the class of operation, vacuum tube and solid state circuits, distortion and intermodulation, spurious and parasitic suppression, microwave amplifiers, switching type amplifiers. Okay, the first question on this one is, for what portion of the signal cycle does each active element in a push-pull class AB amplifier conduct? That would be more than 180 degrees, but less than 360 degrees. And there you see the little drawing, the diagram of the signal waveform.
It
Showing both.
produces a portion below the 180, doesn't it? Down on the other side, the bottom curve.
No, because you've got a small amount that the circuit doesn't bias, so it's not going to conduct until it's biased. So that's what they, it introduces what they call crossover distortion, because it's not going to be fully biased the whole time. A class A amplifier is fully biased the entire time, but it also is very inefficient, and you lose a lot of energy to heat with a class A.
And this doesn't matter what type of amplifier, whether it be a transistor amplifier or a tube amplifier.
No, either one. This is accurate for both.
Gotcha.
All right. What is a Class D amplifier? A type of amplifier that uses switching technology to achieve high efficiency. And this is a little schematic drawing of basically what that would look like.
Yeah, Class D audio amplifiers are used a lot in car sound systems. They can achieve, pretty high power levels without generating a lot of heat. That was always the issue when you had Class AB amplifiers with car sound units. They would generate so much heat that they might go into thermal shutdown. But the Class D, because it's switching so quickly, it doesn't really have time to generate that heat. So they're much more efficient, but they have other limitations, outside of that.
Okay, which of the following components form the output of a Class D amplifier circuit? It would be a low-pass filter to remove switching signal components. Okay, where on the load line of a Class A common emitter amplifier would bias normally be set? It would be approximately halfway between saturation and cutoff. And there again is a small circuit showing what it would look like and the waveform that you would see. Okay, what can be done to prevent unwanted oscillations in an RF amplifier? The answer would be install parasitic suppressors and or neutralize the stage. Okay, which of the following amplifier types reduces even order harmonics? It would be a push-pull. And there again is the drawing of the circuit.
And you
That
can
would
see
be
with a push-pull, one of the transistors is active during one half of the cycle, and then the other one is active during the other half. So in effect, you've got the two transistors pushing and pulling to generate that waveform.
Okay, which of the following is likely result when a Class C amplifier is used to amplify a single sideband phone signal? That would be signal distortion and excessive bandwidth. Okay, how can an RF power amplifier be neutralized? By feeding a 180-degree out of phase portion of the output back to the input. Which of the following describes how the loading and tuning capacitors are to be adjusted when tuning a vacuum tube RF power amplifier that employs a pi network output circuit? That would be the tuning capacitor is adjusted for minimum plate current, and the loading capacitor is adjusted for maximum permissible plate current. Okay, in figure E7-1, what is the purpose of R1 and R2? That is a voltage divider bias. In figure E7-1, what is the purpose of R3? That is self-bias. What type of amplifier circuit is shown in figure E7-1? It's a common emitter. Okay, which of the following describes an emitter follower or common collector amplifier? That would be an amplifier with a low impedance output that follows the base input voltage. There again, here's a little drawing of what that would look like. Okay, why are switching amplifiers more efficient than linear amplifiers? The power transistor is at saturation or cutoff most of the time. What is one way to prevent thermal runaway in a bipolar transistor amplifier? That would be to use a resistor in series with the emitter. The series emitter resistor will limit the current flowing when the transistor is biased full on. Okay. What is the effect of intermodulation products in a linear power supply? transmission of sparse signals. Why are odd order rather than even order intermodulation distortion products of concern in linear power amplifiers? It'd be because they are relatively close in frequency to the desired signal. Okay. What is the characteristic of a grounded grid amplifier? It would be a low input impedance. And there is a drawing of what that would look like.
Yeah, you can see the middle is going to be the grid, and it's tied down to the ground. So that's where they get the name for it.
Okay, next section is filters and matching networks. Types of networks, types of filters, filter applications, filter characteristics, impedance matching, and DSP filtering. Okay, how are capacitors and inductors of a low-pass filter pi network arranged between the network's input and output? Okay, a capacitor is connected between the input and ground. Another capacitor is connected between the output and ground. And an inductor is connected between input and output. This is kind of what I call a very common circuit for, especially in power supplies, for filtering out AC.
Yeah, this is used a lot in antenna tuners or transmatches. And the reason why they call it a pi network is that the shape of the components, it looks like a little Greek letter pi.
All righty. Which of the following is a property of a T network with series capacitors and a parallel shunt inductor? It is a high pass filter. And there again, in this drawing, they're showing two capacitors going between the input and the output with an inductor or coil going between the two capacitors and the ground, or the common. Okay, what advantage does a series L pi L network have over series L pi network for impedance matching between the final amplifier of a vacuum tube transmitter and an antenna? It'd be greater harmonic suppression. And there again, here's your drawing with your adjustable capacitors and the chokes, adjustable coils also between the transmitter and the antenna. All right, how does an impedance matching circuit transform a complex impedance to a resistive impedance? It cancels the reactive part of the impedance and changes the resistive part to a desired value. Okay, which filter type is described as having ripple in the pass band and a sharp cutoff? I hope I get this right. I've never heard of this before. A Chebyshev filter?
Yeah, Chebyshev.
Chebyshev. I have never heard of that one before. That's a new one on me.
Yeah, it's a believe it's named after a Russian who invented the filter.
I would be surprised if that wasn't Russian.
But yeah, you can see there's a little bit of ripple in the pass band, and then you have this sharp cutoff at the end with it.
All righty. What are the distinguishing features of an elliptical filter? They'd be extremely sharp cutoff with one or more notches in the stop band. Okay, and then here's a representative of that, showing what that would look like on probably on a scope. Is what you would see.
That's going to be your notches right there.
Okay, which describes a Pi-L network used for matching a vacuum tube final amplifier to a 50 ohm unbalanced output. That would be a Pi network with an additional series inductor on the output. And they're telling you to see graphic for E7CO3,
Yeah.
which would be
Yeah. So
this
this is,
guy right here.
yeah.
All righty, next. Which of the following factors has the greatest effect on the bandwidth and response shape of a crystal ladder filter? The relative frequencies of the individual crystals. Okay. What is a crystal lattice filter? That is a filter with a narrow bandwidth and steep skirts made using quartz crystals. And there again is a drawing of what that would look like.
And all the old super heterodyne HF transceivers, crystal filters were, the only type of filtering that you could get back in the day. Since then, they've moved to DSP, where a lot of that filtering is done electronically, in an integrated circuit.
Alrighty, which of the following filters would be the best choice for use in a 2-meter band repeater duplexer? That's what they call a cavity filter. Okay, which of the following describes a receiving filter's ability to reject signals occupying an adjacent channel? That would be a shape factor. The sharper the filter, narrower with steep skirts, the better it can reject nearby signals. Okay. What is one advantage of a Pi matching network over an L matching network consisting of a single inductor and a single capacitor? That would be the Q of Pi networks can be controlled. All right, power supplies and voltage regulators, solar array charge controllers. All right, how does a linear electronic voltage regulator work? The conduction of a control element is varied to maintain a constant output voltage. And here again is a common circuit of how that's done. And usually you have a higher voltage going in. In this case, they're showing 28 volts max. And then you would, by adjusting R1, you can control the actual voltage output. All right, what is a characteristic of a switching electronic voltage regulator? The controlled device's duty cycle is changed to produce a constant average output voltage.
Yeah, so with a switching voltage regulator, instead of having a single continuous straight line for your output, it's basically built up of little spikes very close together, and it averages out to the output voltage.
Alrighty, what device is typically used as a stable voltage reference in a linear voltage regulator? That would be a Zener diode. Which of the following types of linear voltage regulator usually make the most efficient use of the primary power source? That would be a series regulator. This is because the regulator circuit only dissipates power as a function of the load current. Power dissipated is the voltage drop across the regulator. Okay, the next one, which of the following types of linear voltage regulator places a constant load on the unregulated voltage source? That would be a shunt regulator. Since a shunt regulator always draws a constant power regardless of the current. Alrighty, what is the purpose of Q1 in the circuit shown in figure E7-2? It controls the current supplied to the load. Okay, and there again is your little drawing there showing the schematic of what it incorporates. And they're basically also using that Zener diode to control the actual turn on and cut off of the Q1. Alrighty, what is the purpose of C2 in the circuit shown in figure E7-2? It bypasses rectifier output ripple around D1. All right, what type of circuit is shown in figure E7-2? It is a linear voltage regulator.
Do we want to flip back to that
Yeah, I
figure?
guess. Yeah, just
Yeah.
that's basically a linear voltage regulator. All right, what is the main reason to use a charge controller with a solar power system? That would be prevention of battery damage due to overcharge. The output voltage of a solar cell varies as a function of intensity of the light hitting it. A 12-volt solar array, 24 each, half-volt solar cells in series will produce as much as 17 volts DC in strong light and 0 voltage with no light. A voltage regulator charge controller will prevent excessive charge voltage to the battery in strong light conditions, and a series diode prevents discharge of the solar panel output drops below the battery voltage.
I'm holding up my solar charge controller for my solar panel.
All righty. What is the primary reason that a high frequency switching type high voltage power supply can be both less expensive and lighter in weight than a conventional power supply? The high frequency inverter design uses much smaller transformers and filter components for an equivalent power output. And here again is a block diagram of basically what that entails for these switching high frequency inverters that are used for these switching power supplies. This is something that's, I don't know when exactly they started using these switching power supplies, but it's fairly new. It used to be every power supply was a bulky transformer and then other components to rectify and take the ripple out and smooth it out and regulate it and everything. And now you've got these high frequency inverter type switching supplies that are really taking over in essence.
What is it switching in there? Gene, do you know? Is it switching the negative of the voltage and you only have positive?
Basically what it's switching, from what I know of it, like I said, I haven't done too much work on it, is the high frequency is switching. In other words, when you put in 60 cycles into a lot of these things and it jacks it up to something like a couple of thousand cycles, and it's turning it on and off real fast, and they're able to get away without using all these, big heavy transformers and a lot of components. And that's why most of your new power supplies you get with everything is a tiny little box. It's not much bigger than a couple of little match boxes.
Instead of the transformer, instead of transforming 60 cycles, it may be transforming 300 or 4,000 cycles.
Yes,
Which
I heard one of them one time was like 15,000 cycles. I mean, it's ridiculous.
Yeah, and that's part of the issue that some people have with the switching power supplies is that that switching noise can, fall, within the bands, and you'll actually hear it on the radio. Most newer modern ones, you don't really have that issue. But if you look, we've got the linear power supplies at the clubhouse, and they probably weigh 30 to 35 pounds because of the transformer. And I'm sure Gene can tell you just how big some of those filter capacitors can be.
Yeah.
I've got I guess it's a 30 amp linear power supply that honestly, it's about the size of two paperback books stacked on each other. And haven't noticed any noise with it.
But don't stub your toe on it, huh?
No, not it's. I prefer to drop that on my foot than that 30-pound linear with that big old transformer in that.
Yeah, when I years ago when I first got into like the CB radio, the one I had was a 20 amp. It was basically a battery charger power supply, and it had two huge capacitors in it. They were about the size of about an 8-ounce mug or drink cup in it, and the damn thing weighed somewhere like Chris was saying around 30 pounds or so. And you drop that thing, you're going to feel it.
Yeah. Okay.
All right. What is the function of the pass transistor in a linear voltage regulator circuit? It maintains constant output voltage over a wide range of load currents. Okay, what is the dropout voltage of an analog voltage regulator? It would be the minimum input to output voltage required to maintain regulation. What is the equation for calculating power dissipated by a series linear voltage regulator? That would be the voltage difference from the input to output multiplied by the output current. And here the power dissipation is equal to the input voltage, output voltage, and current. Okay, what is the purpose of connecting equal value resistors across power supplies, filter capacitors connected in series? It would be all of the above are correct, and I'll read them off. It's to equalize the voltage across each capacitor, discharge the capacitors when voltage is removed, and provide a minimum load on the supply. I don't know if any of y'all have ever got bit by a capacitor, but they do bite. And that's another reason for the resistor across it. But if you're not sure whether it has a charge in any capacitor, the best thing is either take a small jumper wire or screwdriver or something, depending on what type of capacitor it is, and short it out, because you can really see a spark on some of these things when you short them out, or they do bite. And believe me, it will leave a burn on your fingers or wherever it hits.
Yeah, I mean, if you think back in the old days, with television sets, when you're trying to drive a CRT, you're talking about kilovolts across a capacitor. And, you short yourself on that and you're taking a dirt nap. It's all game over.
Like I say, they do bite and you will feel it.
Yeah. Just don't want it to be the last thing you feel.
Yeah. I don't know if anybody says got killed off of one of those things, but they definitely wake you up. All righty. What is the purpose of a step start circuit in a high voltage power supply? It allows the filter capacitors to charge gradually. Step start is applying the high voltage to the filter capacitors in steps, allowing the capacitors to charge slower and less abruptly.
And that is it for section 6.
Okay.
No, I'm sorry. This is part E. I think this is maybe the last one.
Yeah, it's E7. Okay. Modulation and demodulation, reactance, phase, and balance modulators, detectors, and mixer stages. Okay, which of the following can be used to generate FM phone emissions? That would be a reactance modulator on the oscillator. Okay, in the oscillator circuit, the output frequency is changed using the modulation signal to change the reactance of the oscillator inductor or capacitor to change its frequency or phase, FM or PM.
And that's frequency modulation and phase modulation.
Okay. What is the function of a reactance modulator? To produce PM or FM signals by using an electrically variable inductance or capacitance. Okay, what is the frequency discriminator stage in an FM receiver? That would be a circuit for detecting FM signals. And here again is kind of a common detector stage showing the transformer, the diodes, and the net filter capacitance network to the audio output. And they show the waveform that would be seen. Okay, what is one way a single sideband phone signal can be generated? By using a balanced modulator followed by a filter. The output of a balanced modulator would be the carrier and both the upper and lower sidebands. A bandpass filter can be used to select only one sideband and not the carrier or the other sideband. Okay, which circuit is added to an FM transmitter to boost the higher audio frequency? It would be a pre-emphasis network. Pre-emphasis is the first part of a noise reduction technique in which a signal's weaker audio higher frequencies are boosted before they are transmitted. Upon receiving, a de-emphasis filter is applied to the audio to reverse the process. This reduces the overall signal to noise of the received signal.
Yeah, and this is very much, if you remember cassette tapes, a very similar process to what was used for noise reduction there with like Dolby B and Dolby C, and really probably more accurate would be DBX, which was, it would go ahead and compress that signal down, and it would transmit it, it would be recorded on there, and then it would be decompressed during playback, and it retains, you know, much better sound quality afterwards by using that than if it had just been recorded straight and played back.
All right. Why is the de-emphasis commonly used in FM communication receivers? For compatibility with transmitters using phase modulation. Okay, what is meant by the term baseband in radio communications? The frequency range occupied by a message signal prior to modulation. What are the principal frequencies that appear at the output of a mixer circuit? The two input frequencies along with their sum and difference frequencies. Okay, what occurs when an excessive amount of signal energy reaches a mixer circuit? Sparse mixer products are generated. How does a diode envelope detector function? By rectification and filtering of RF signals. Okay, what type of detector circuit is used for demodulating single sideband signals? That would be a product detector. A product detector is a type of demodulator used for AM and single sideband signals. Rather than converting the envelope of the signal into a decoded waveform like an envelope detector, the product detector uses the product of the modulated signal and a local oscillator, hence the name. A product detector is basically a frequency mixer. Okay, next section is DSP filtering and other operations. Software-defined radio fundamentals, DSP modulation, and demodulation. Okay, what is meant by direct digital conversion as applied to software-defined radios? Incoming RF is digitized by an analog to digital converter without being mixed with a local oscillator signal. Okay, what kind of digital signal processing audio amplifier is used to remove unwanted noise from a received single sideband signal? That would be an adaptive filter. The term adaptive filter implies changing the characteristic of a filter in some automated fashion to obtain the best possible signal quality despite changing signal system conditions. All right, what type of digital signal processing filter is used to generate a single sideband signal? That is a Hilbert transform filter. Digital Hilbert filters are a special class of digital filter whose characteristic is to introduce a pi divided by 2 radians phase shift of the input signal. In the ideal Hilbert transform, all the positive frequency components are shifted by negative pi divided by 2 radians, and all the negative frequency components are shifted by pi divided by 2 radians. But it's a mouthful.
Yeah, it's named after British physicist David Hilbert. He was physicist and mathematician, and very, very, very famous, when you talk about Hilbert space, when you're talking about multivariate calculus. I remember him well from graduate school.
All right, what is the common method of generating a single sideband signal using digital signal processing? Signals are combined in a quadrature phase relationship. Quadrature refers to 2 sinusoids that have the same frequency and are 90 degrees out of phase. Okay, how frequently must an analog signal be sampled by an analog to digital converter so that the signal can be accurately reproduced? At least twice the rate of highest frequency component of the signal. So for a 10 megahertz signal, the sampling rate would need to be at least 20 megahertz.
And if you remember when compact audio discs came out in the early 80s, the audio for the compact disc is sampled at 44.1 kilohertz. And if you use the accepted range of human hearing, which is 20 hertz to 20 kilohertz, by sampling at 44.1 kilohertz, that's a bit over twice the highest frequency of that signal. Nowadays, if you get high resolution audio, they'll sample it, up, in the 300 plus kilohertz range for the hopes of getting, just that little bit more signal to come out. So, but this also applies for any kind of signal, not just audio.
Okay. What is the minimum number of bits required for an analog to digital converter to sample a signal with a range of 1 volt at a resolution of 1 millivolt? That would be 10 bits. Okay, what function is performed by a fast Fourier transform? That would be converting digital signals from the time domain to the frequency domain. And here again, they give you an example of the waveforms that you would see on a time domain and the actual frequency domain.
If you look at, the Flex or the IC 7300 at the clubhouse, this is what you're seeing coming into the antenna input. And then the fast Fourier transform, or FFT, is going to convert it into the frequency domain. So when you look at the screen, you'll be able to see the signals across the frequency that way instead of across time.
All righty. What is the function of decimation? Reducing the effective sample rate by removing samples. Okay, why is an anti-aliasing digital filter required in a digital discriminator? It removes high frequency signal components that would otherwise be reproduced as lower frequency components. Okay, what aspect of a receiver analog to digital conversion determines the maximum receiver bandwidth of a direct digital conversion SDR? It would be the sample rate. Okay, what sets the minimum detectable signal level for a direct sampling SDR receiver in the absence of atmospheric or thermal noise? That would be the reference voltage level and sample width in bits. Okay, which of the following is an advantage of a finite impulse response filter versus an infinite impulse response digital filter? FIR filters can delay all frequency components of the signal by the same amount. So a finite impulse response FIR filter is a filter whose impulse response is a finite duration because it decays to 0 in finite time. This is in contrast to an infinite finite impulse response IIR filter, which continues to respond indefinitely. Okay, what is the function of taps in a digital signal processing filter? They provide incremental signal delays for filter algorithms. Which of the following would allow a digital signal processing filter to create a sharper filter response? It would be more taps. The number of FIR taps, often designated as N, in an indication of the amount of memory required to implement the filter, the number of calculations required, the amount of filtering the filter can do. In effect, more taps means more stop band attenuation, less ripple, narrower filters, etc. All right, active filters and op-amp circuits, active audio filters, characteristics, basic circuit design, and operational amplifiers. Okay, what is the typical output impedance of an op-amp? Very low. What is ringing in a filter? That's undesirable oscillations added to the desired signal. And here again, they show you a little what that would kind of look like, showing the ringing after the desired signal. They call it an error band. Okay. What is the typical input impedance of an op-amp? Very high. What is meant by the term op-amp input offset voltage? That would be the differential input voltage needed to bring the open loop output voltage to 0. Okay, how can unwanted ringing and audio instability be prevented in an op-amp RC audio filter circuit? Restrict both gain and Q. Okay, what is the gain bandwidth of an operational amplifier? The frequency at which the open loop gain of the amplifier equals 1. Okay, what magnitude of the voltage gain can be expected from the circuit in figure E7-3 when R1 is 10 ohms, RF is 470 ohms? That would be 47. Gain is equal to feedback resistor divided by input resistor, or gain is equal to 470 divided by 10, or 47. And here's a little drawing showing the circuit. Okay, how does the gain of an ideal operational amplifier vary with frequency? It does not vary with frequency. Of course, there is no ideal or perfect operational amplifier, so therefore there are some real limits.
Yeah, the closer to an ideal operational amplifier, the more expensive that part becomes.
All righty, what will the output voltage of the circuit shown in figure E7-3 if R1 is 1,000 ohms, RF is 10,000 ohms, and 0.23 volts DC is applied to the input? That would be negative 2.3 volts.
Okay, I'm going to
There
flip
again.
back. This is what we're E7-3.
There again, here is your formula: is output is equal to feedback resistor divided by input resistor divided by input voltage divided by -1, or 0.23 volts be divided by 10,000 divided by 1,000 divided by -1, or 0.23 volts divided by 10 divided by -1, or would be negative 2.3 volts. Okay, the multiply by -1 is because this is an inverting amplifier. If the input is positive, then the output will be negative, and the input is negative, the output will be positive.
You know, if we look, we're feeding the op amp on the negative side. So it's going to invert that signal. If we fed it on the positive side, then it would actually become a positive gain instead of a negative.
Okay, what absolute voltage gain can be expected from the circuit in figure E7-3 when R1 is 1800 ohms and RF is 68 kilo ohms? That would be 38. Gain is equal to feedback resistor divided by input resistor, or 68,000 divided by 1800 would be 37.78. Okay, what is the absolute voltage gain can be expected from a circuit in figure E7-3 when R1 is 3,300 ohms and RF is 47 kilo ohms? That would be 14. Here, the gain is equal to the feedback resistor divided by the input resistor, or 47,000 divided by 3,300 would be 14.24. Okay, what is an operational amplifier? A high gain, direct coupled differential amplifier with a very high input impedance and a very low output impedance.
And what they mean by differential is you have both a positive and a negative input.
All right, oscillators and signal sources, types of oscillators, synthesizers, and phase locked loops, direct signal synthesizers, stabilizing thermal drift, microphonics, high accuracy oscillators. Okay, what are the 3 oscillator circuits used in an amateur radio equipment? It would be the Colpitts, Hartley, and Pierce. What is a microphonic? It is changes in oscillator frequency to mechanical vibration.
Yeah, so if you were to hit the oscillator mechanically, like, you know, tap it, then it would change the frequency. You know, think of like a tuning fork. If you touch it while it's vibrating, it's going to change the frequency slightly.
Okay, how is positive feedback supplied in a Hartley oscillator? It's through a tapped coil. When you think of a Hartley, think H for Henry's or inductance. And there you go. There's a little schematic showing you the two L1 and L2 coils. Okay. How is positive feedback supplied in a Colpitts oscillator? Through a capacitive divider. When you think of a Colpitts, think of C or capacitance. And there again is the schematic showing the C1 and C2 in that arrangement. Okay, how is positive feedback supplied in a Pierce oscillator? Through a quartz crystal. So when you think of a Pierce, think P for piezoelectric quartz crystal. And there you see the little schematic with the schematic diagram of a crystal is a little rectangle with two lines, one on each side. Okay, which of the following oscillator circuits are commonly used in VFOs? Colpitts and Hartley. How can an oscillator's microphonic responses be reduced? Mechanically isolate the oscillator circuitry from its enclosure. Mechanical vibration of the elements, especially a tuning capacitor, will result in its value to change slightly. Okay, which of the following components can be used to reduce thermal drift in crystal oscillators? That's NPO capacitors. A NPO ceramic capacitor is an ultra-stable or temperature compensating capacitor. It is one of the most highly stable capacitors. It has a very predictable temperature coefficient, which are TCs, and in general, does not change value with time. All righty, what type of frequency synthesizer circuit uses a phase accumulator, lookup table, digital to analog converter, and a low pass anti-alias filter? That's a direct digital synthesizer. Direct digital synthesize, DDS, is a method of producing an analog waveform, usually a sine wave, by generating a time varying signal in digital form and then performing a digital to analog conversion. Because operations within a DDS device are primarily digital, it can offer fast switching between output frequencies, fine frequency resolution and operation over a broad spectrum of frequencies.
That's a mouthful.
Yeah. All right, what information is contained in a lookup table of a direct digital synthesizer, DDS? That would be amplitude values that represent the desired waveform. Okay, what is the major spectral impurity components of a direct digital synthesizers? That would be sparse signals at discrete frequencies. Okay, which of the following must be done to ensure that a crystal oscillator provides the frequency specified by the crystal manufacturer? Provide the crystal with a specified parallel capacitance. Okay, which of the following is a technique for providing highly accurate and stable oscillators needed for microwave transmission and reception? That would be, D would be the answer for this. All is correct. I'll read them off. Is use a GPS signal reference, use a rubidium stabilized reference oscillator, and use a temperature controlled high Q dielectric resonator. A rubidium reference is based on a molecular resonance frequency of a capsule of rubidium gas, which is precisely 6,834.682, or 610.9004 hertz. This frequency is typically translated to a 10 megahertz frequency. A dielectric resonator is a piece of dielectric, non-conductive material, usually ceramic, that is designed to function as a resonator for radio waves, generally in the microwave bands. Okay, what is a phased lock loop circuit? An electronic servo loop consisting of a phase detector, a low pass filter, a voltage controlled oscillator, and a stable reference oscillator. And here again is a little diagram of what that would look like. Okay, which of these functions can be performed by a phased lock loop? Frequency synthesis and FM demodulation. And there again is your little block diagram of what that would be basically looking like.
All right, we are at the end, finally. Wow.
Chris, I got a question on all of those that we just went through.
Yeah,
How many questions of that series do they usually have on the test?
I got that. It says 8 exam questions for the 8 groups, which is 108 questions total. But they say 8 exam questions on the exam, I guess.
yeah. So you're
But
probably
you want one
looking at,
from each group.
yeah, probably looking at one, per sub element or section of each sub element for that one.
Okay,
It had 8 groups. It had A through H
Yeah,
is the groups. And it had a total of 108 questions in the whole E7 group. And then they start off with, they say that 8 exam questions.
yeah, there's a lot of stuff there to learn
yeah.
or memorize.
Well, let's try and get through the practice real quick, because I know we're pretty long tonight. Okay, which circuit is bistable?
Hey,
Hey,
Yeah, A. What is the function of a decade counter?
Hey,
Yeah, giveaway decade. So
yeah, right. 10.
which of the following can divide the frequency of a pulse train by 2?
B, flip flop.
Yeah, that's going to be a flip flop.
be a flip flop.
And if we want to divide it by 4, we need to have
B,
B,
2.
2.
2 flip flops. Which of the following is a circuit that continuously alternates between 2 states without an external clock?
That's a C. Nope.
No external clock, so it's going to be astable.
Stable multivibrator.
What is a characteristic of a monostable multivibrator?
hey,
A.
Yeah, it's going to be A. What logical operation does a NAND gate perform?
it should produce one everywhere except where it's the both inputs are 1. So whatever one that translates to.
B.
Yeah, so I believe it's B. What logical operation does an OR gate perform?
Hey.
I don't know. I'm going.
Yeah,
So
that's
you have
gonna
the
be
2
A.
inputs, and if one is logic 1 or the other is logic 1, or if both are logic 1.
Yeah, it's A.
It was A, yeah.
Only one with 4.
Okay, now remember exclusive, if they're both logic 1, that doesn't count. It's only if one of the two.
Yeah. It would be C, huh?
B.
C, if logic 1 and only if 1, yeah.
Okay,
No,
so if one of the inputs is logic 1, then the output of an OR gate would be logic 1, and then you NOR it, so that would become 0. So
It's A.
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 What is the truth table?
A.
A.
Yeah. What type of logic defines 1 as a high voltage?
C.
C.
B.
C, positive. Okay, not bad. For what portion of the signal cycle does each active element in a push-pull class AB amplifier conduct?
A.
Yeah, that's going to be A.
A.
What is a class D amplifier?
A.
Yeah, A again. Which of the following components form the output of a class D amplifier circuit?
C.
Yeah, C. Where on the load line of a class A common emitter amplifier would bias normally be set?
D.
So, yeah, halfway between saturation and cutoff. What can be done to prevent unwanted oscillations in an RF power amplifier?
D.
Yeah, D.
I got to get in now because later I have no clue.
Which of the following amplifier reduces even order harmonics?
D.
Yeah, a push-pull.
Push-pull. D.
Which of the following is a likely result when a class C amplifier is used to amplify a single sideband phone signal?
B.
B.
Signal distortion and excessive bandwidth. How can an RF power amplifier be neutralized?
B.
Yeah. Which of the following describes how the loading and tuning capacitors are to be adjusted when tuning a vacuum tube RF power amplifier that employs a pi network output circuit?
C.
C?
C.
Yeah. Okay, figure 7.1, what is the purpose of R1 and R2?
B.
Well,
It's a voltage divider.
D.
C.
B.
It's going to be the voltage
Oh,
divider.
C.
Said that.
Okay, what is the purpose of R3?
C.
B.
It's A, output resistor.
Well, that's on the emitter of the transistor.
Okay.
B.
Can be self-biasing.
D.
Yeah, so it's going to be self-bias.
Right, yeah.
What type of amplifier is shown in figure E7.1?
See?
Just say, emitter follower.
C, common collector,
Common.
common emitter. Which of the following describes an emitter follower or common collector amplifier? Okay, elements. Say C.
Yeah.
Why are switching amplifiers more efficient than linear amplifiers?
C,
D.
What is one way to prevent thermal runaway in a bipolar transistor amplifier?
A,
Yeah, we want to put a resistor in series with the emitter. What is the effect of intermodulation products in a linear power amplifier?
A.
Yeah, spurious signals. Why are odd order rather than even order intermodulation distortion products of concern in linear power amplifiers?
B.
Yeah, they're going to be close in frequency to the desired signal. What is a characteristic of a grounded grid amplifier?
B,
Low input impedance. Okay. How are the capacitors and inductors of a low-pass pi network arranged between the network's input and output?
A.
Yeah, A. Which of the following is a property of a T network with series capacitors and a parallel shunt inductor?
B.
Not a low pass. Not a notch. High pass. What advantage does a series L pi L network have over a series L pi network for impedance matching between the final amplifier of a vacuum tube transmitter and the antenna?
B. C.
Yeah, greater harmonic suppression. How does an impedance matching circuit transform a complex impedance to a resistive impedance?
A,
Yeah, A. So to get rid of the reactive and transform the resistive to the desired value. Which filter type is described as having ripple in the pass band and a sharp cutoff?
Chevy Chase filter,
Chevy.
B,
Yeah.
I'll go with B
Chase.
because it's a fun word, so I'll go with B.
What are the distinguishing features of an elliptical filter?
A,
Yeah. Which describes a pi L network used for matching a vacuum tube final amplifier to a 50 ohm unbalanced output?
C.
Yeah, so it's going to be C. You've got the pi, and then you're adding on an L to it, so that's going to be that additional inductor on the output. Which of the following factors has the greatest effect on the bandwidth and response shape of a crystal ladder filter?
A.
B.
A. What is a crystal lattice filter?
C.
Yeah, it's going to be C. Which of the following filters would be a best choice for use in a 2-meter band repeater duplexer?
C again. Cavity.
Yeah, a cavity filter.
Oh, yes.
Which of the following describes a receiving filter's ability to reject signals occupying an adjacent channel?
Shape factor.
Shape factor.
Yeah.
What is one advantage of a pi matching network over an L matching network consisting of a single inductor and a single capacitor? It's going to be C. The
C.
Q can
C.
be controlled. Okay, next section. How does a linear electronic voltage regulator work?
A.
Yeah, that's going to be A. What is a characteristic of a switching electronic voltage regulator?
D.
Yeah, it's going to be D. What device is typically used as a stable voltage reference in a linear voltage regulator?
C.
C, yeah, Zener.
C.
Zener diode. Which of the following types of linear voltage regulator usually make the most efficient use of the primary power source?
BC, a shunt regulator.
C.
Oh,
Well, I'm going to say series. To remember a shunt, it's going to keep it under constant load. So the answer for this one is going to be a shunt. So what is the purpose of Q1 in the circuit shown in E7-2?
D.
D.
Yeah, correct. What is the purpose of C2 in the circuit?
Yeah, I think that's it. A.
Yeah. What type of circuit is shown in figure E7-2?
CB.
Linear voltage regulator. What is the main reason to use a charge controller with a solar power system?
D. Delta.
Yeah, correct. What is the primary reason that a high frequency switching type high voltage power supply can be both less expensive and lighter in weight than a conventional power supply?
C.
Yeah.
C.
C.
What is the function of the pass transistor in a linear voltage regulator circuit?
B.
Okay, this is going to be B. What is the dropout voltage of an analog voltage regulator? And this is going to be that minimum required to maintain regulation. What is the equation for calculating power dissipated by a series linear voltage regulator?
C, Charlie.
Yeah,
See,
difference in voltage times the current. What is the purpose of connecting equal value resistors across power supply filter capacitors connected in series?
Discharging.
D, C.
Yeah, Gene's got it. All of these are
Mhm.
correct. What is the purpose of a step start circuit in a high voltage power supply?
A.
Yeah.
Only 20 more sections to go.
Only 4. We're moving quickly though. Which of the following can be used to generate FM phone emissions?
A.
I'll go with B. Why not?
Yeah.
No, odd.
Shit. Final, on the final.
Oh, D.
Damn it.
I'm all in for D.
Last one left.
What is the function of a reactance modulator?
C.
Yeah, I'll go with C.
What is a frequency discriminator stage in an FM receiver?
Oh, C.
Yeah, that's going to be used to detect the FM signals. What is one way a single sideband phone signal can be generated?
Modulator followed by a filter. A.
Yeah. Yeah, A. Which circuit is added to an FM transmitter to boost the higher audio frequencies?
C.
C.
Yeah, pre-emphasis. Why is de-emphasis commonly used in FM communications receivers?
Compatibility. I remember the word compatibility.
Yeah, compatibility. What is meant by the term baseband in radio communications?
A.
It's going to be C.
C.
What are the principal frequencies that appear at the output of a mixer circuit?
It's gonna be D.
A.
Yeah, it's going to be A. You know, the inputs along with the sum and differences. What occurs when an excessive amount of signal energy reaches a mixer circuit?
B.
Yeah.
Yeah, B. How does a diode envelope detector function?
Wow. I have no idea on this one.
B.
B, C,
I'll go with B.
B, yeah. What type of detector circuit is used for demodulating single sideband signals?
I would say B.
Product detector.
You know, being a general is not a bad thing.
A lot of these you really, you know, you're gonna memorize it for the exam and never really use it. What is meant by direct digital conversion as applied to software-defined radios?
Direct D, no oscillator.
Yeah, so you're gonna analog to digital convert it with no mixer. What type of digital signal processing audio filter is used to remove unwanted noise from a received single sideband signal?
D, Hilbert.
D, yeah.
Yeah, go with Hilbert. Why not? No,
Oh,
definitely not Hilbert.
A,
A, B,
Okay,
A,
B,
B,
bravo.
B.
What type of digital signal processing filter is used to generate a single sideband signal?
C, Hilbert.
C,
Yeah, that's where he comes in.
My boy Hilbert.
What is a common method of generating a single sideband signal using digital signal processing?
C,
So C. Oh, come on.
D,
Yeah, D. How frequently must an analog signal be sampled by an analog to digital converter so that the signal can be accurately reproduced?
at least twice.
Yeah,
C.
at least twice. What is the minimum number of bits required for an analog to digital converter to sample a signal with a range of 1 volt at a resolution of 1 millivolt?
C, Charlie,
C, M W.
What function is performed by a fast Fourier transform?
that's
A.
the frequency to the A, frequency to
Yeah,
time.
time to domain.
Yeah,
Frequency.
Oh, I look,
What is the function of decimation?
Oh, removing samples, A.
Yeah, we're going to remove some samples. Why is an anti-aliasing digital filter required in a digital decimator?
That's A as well.
Yeah, A. What aspect of receiver analog to digital conversion determines the maximum receive bandwidth of a direct digital conversion SDR?
sample rate, B,
D.
Yeah, the sample rate. What sets the minimum detectable signal level for a direct sampling SDR receiver in the absence of atmospheric or thermal noise?
Delta.
D,
Yeah, delta. Which of the following is an advantage of a finite impulse response FIR filter versus an infinite response impulse response digital filter?
That's B.
What is the function of taps in a digital signal processing filter?
that's gonna be C.
C, yeah.
Yeah, C. Which of the following would allow a digital signal processing filter to create a sharper filter response?
or taps, D,
More taps, more cowbell. All right, I think we're down to just 2. Yeah, just 2.
Oh my.
What is the typical output impedance of an op amp?
how could it be C, I,
It's going to be very low.
hold on,
The input impedance is going to be very high.
Okay.
What is
No
ringing?
current in, current out.
So ringing, that's going to be those undesired oscillations getting added.
Hey, Chris, y'all keep going. I gotta step away for 1 second.
Okay. What is the typical input impedance of an op amp? Just kind of mention,
High, D.
D,
yeah, very high.
Yeah.
What is meant by the term op amp input offset voltage? Okay. Trick to remember when this one is the output voltage will be 0. How can unwanted ringing and audio instability be prevented in an op amp RC audio filter circuit?
A.
B,
Yeah, we want to restrict gain and Q. What is the gain bandwidth of an operational amplifier?
Say B.
D, B,
Nope, that's not it.
say D.
D. Nope.
See,
Because I wish to open up.
what magnitude of voltage gain can be expected from the circuit when R1 is 10 and RF is 470?
D,
Yeah, RF over R1. How does the gain of an ideal operational amplifier vary with frequency?
It does not vary.
Yeah, see, it doesn't vary. What will be the output voltage of the circuit shown if R1 is 1,000 ohms, RF is 10,000 ohms, and 0.23 volts of DC is applied to the input?
it's gonna be B.
So we've got RF over R1, so that's going to be 10 times 0.23, so that's 0.23, but we're feeding it on the negative side, so it's going to be negative 2.3. What absolute voltage gain can be expected from the circuit when R1 is 1,800 ohms and RF is 68 kilo ohms? So
It's in the third, got to be in the 30s, so I'll say C,
Yeah.
38.
Yeah, 38.
yeah, 38. What absolute voltage gain can be expected from the circuit when R1 is 3,300 ohms and RF is 47 kilo ohms?
Calculator.
14? Does that work?
Is it 14? Yeah. What is an operational amplifier?
C,
Yeah, C.
Yeah, C. All right. I believe this is the last one. What are the 3 oscillator circuits used in amateur radio equipment?
it's gonna be A.
Hey,
Yeah, A. What is a microphonic?
C.
C,
Hey, Charlie.
Yeah, Charlie, yeah. How is positive feedback supplied in a Hartley oscillator?
C.
I remember Hartley, H,
H.
Henry's,
I'd say
Pack
A.
coil, D, yeah.
Yeah,
Pat coil.
D, yeah.
How is positive feedback supplied in a coal pits oscillator?
That's
It's
C.
gonna be C.
Yeah, coal pits, capacitive. How is positive feedback supplied in a Pierce oscillator? So Pierce, piezo,
A, the quartz crystal.
yeah, quartz crystal. Which of the following oscillator circuits are commonly used in VFOs?
D.
Yeah, coal pits and Hartley. How can an oscillator's microphonic responses be reduced?
C.
Yeah,
C.
isolated mechanically. Which of the following components can be used to reduce thermal drift in crystal oscillators?
It's gonna be B.
Yeah, NPO capacitors. What type of frequency synthesizer circuit uses a phase accumulator, lookup table, digital to analog converter, and a low pass anti-alias filter?
It's gonna be B.
D, delta.
It would be.
Direct digital synthesizer. What information is contained in the lookup table of the direct digital synthesizer?
D.
Amplitude value.
Yeah.
What are the major spectral impurity components of a direct digital synthesizer?
Bravo.
B, yeah.
Yeah, bravo. Which of the following must be done to ensure that a crystal oscillator provides the frequency specified by the crystal manufacturer?
Hmm.
Three. Dang, okay.
Capacitance. Which of the following is a technique for providing highly accurate and stable oscillators needed for microwave transmission and reception?
D, delta.
D.
Yeah, all of these are correct. What is a phase lock loop circuit? Okay, well, we know it doesn't have a push-pull, and it's not a monostable multivibrator.
I think it's gonna be D.
Yeah, I think it's going to be D. Which of these functions can be performed by a phase lock loop?
It's gonna be C.
Yeah, C. All right, was that it?
That's it.
That was it. All right. Anybody have any questions? I know this was a long one tonight.
Hopefully, maybe they'll just not ask some of these questions.
Yeah,
Uh,
well, I'm going to stop.